Hello dear students, welcome to my YouTube channel. In this lesson I am going to explain Kirchhoff rules. Okay, so Kirchhoff rules are applied in a situation where we can't apply series and parallel combination of circuits. Okay, so in order to find the current or resistance or anything in the complex circuit, we need Kirchhoff rules. Okay, so some circuits can't be broken down into series and parallel connections. For those circuits, we use Kirchhoff rules. Okay, so there are two rules. Kirchhoff defined two rules. First rule, Kirchhoff first rule, that is also known as the KCL or junction rule. KCL means the Kirchhoff current law, and junction rule is another name of the first law. Okay, so first of all, I want to define the Kirchhoff first law. The sum of current entering a junction is equal to the sum of current leaving it. So definitely when a current enters into a junction, the sum of current entering a junction must be equal to the sum current leaving from that junction. The entering current must be equal to leaving current. So this is basically conservation of charge. The charge that is entering a point, it must be equal to the charge leaving that point. Okay, this is conservation of charge. Okay, so I will explain in detail. So how the what is mean by statement. So for example, if we have a wire that has resistance R1, first wire, another wire that has resistance R2, so I want to define first what is mean by junction. This point, word junction. Junction is a point where two or more wires meet. A point where two or more wires meet or is point is called junction. So here is junction J, where R1 R2 wires, both wires, first and second wire meet. So and the R3 and R4, suppose R3 and R4 are the two wires that leaving from that junction. Okay, now suppose that I1 current that enters into the junction and the current I2 that also enters into the junction J, and I3 and I4 are the currents that leaving from that junction. So according to first rule, first law, I1 plus I2, sum of current that enters into a junction must be equal to I3 plus I4. So this is simple conservation of charge. The current entering must be equal to current leaving. The current entering must be equal to the current leaving. So for example, let I give you another simple example. For example, if we have 5 ampere is entering, I1 is 5 ampere and I2 is for example 6 ampere, that makes 11 ampere. So 11 ampere is entering into the junction. Okay, so for example I3 is 7 ampere, then I4 must be equal to 4 ampere, so that makes 11. So the current entering is equal to 5 ampere plus 6 ampere, which is equal to 11 ampere, and the current leaving I3 is 7 ampere, and then I4 must be equal to 4 ampere, so that makes 11 ampere. So the current entering into the junction must be equal to current leaving the junction. So this is conservation of currents or conservation of charge. Okay, one more thing. Okay, let me explain in a different way. So I will continue. Okay, so what is junction? So a definition: a junction is also known as a node, is a point of circuit where three or more conducting wire meets. Okay, it is a place where the current can split or combine. Okay, so point where the current is combined or living at a point is called the junction, or it is also known as the node. Okay, I have to define the KCL in another way. For example, suppose I will give you another example, simple example. Suppose I1, for example, current I1 that enters into the junction, this junction, and then we have two wires, I2 and then I3, I2 and I3. So the current entering I1 must be equal to I2 plus I3. So the current that enters is I1, the current that leaves is I2 plus I3. So the total current enters must be equal to the total current that leaves from the junction. Okay, so another example, for example, another scenario, for example, if we have a wire, in sometimes we don't know the direction of current. For example, we don't know the direction of exact current. For example, we have three wires, I1, I2 and I3. R1, R2 and R3 are the resistance of 3 wires. This is R3 and this is R2, for example. R1, R2 and R3, 3 wires, they meet at the junction. So in this example, suppose that, let me explain, suppose that, for example, 10 ampere current that is entering into the junction. Okay, now for example 6 ampere is living in this junction, 6 ampere is living there, and but we don't know this current I2, we don't know. This is I3, for example, I3 is entering into the junction, and then I1 that is living in the junction, I1 is that is living, and I2 we don't know that. For example, we don't know the magnitude and direction of this R2, the current that living or entering or leaving this junction. We don't know the current that enters or leave from this R2. So we define Kirchhoff rule in another way. So this rule is this statement, the second statement of Kirchhoff rule is sum of all current meeting at a junction must be equal to 0. So sum of all currents meeting at a junction must be equal to 0. So what does it mean? It means that the current, total sum of current must be equal to 0. So in this case we need to define the direction, current direction. Direction. So current direction. So for the direction, the current towards a point, the current that enters or towards a point. So 1 minute. I have to remove this one and again. The current that enters towards a point, we have to set the direction. So the current direction is the current towards a point, 1 minute, towards a point is taken as positive, and the current that moves away is taken as negative. Okay, so sum of current, so I1, so this is I3 that is moving towards a junction, so it is taken as I3 plus I3. Okay, now I1 that is moving away, so it is negative, I1 is negative, and I2 we don't know about I2, I2. What is I2? Which is equal to 0. So I2 is equal to 0. So we have to find I2. So in order to find I2, we just for example this is 10 ampere minus, because this is moving away, so we have I1 is 6 ampere, and this one I2 we don't know about this one, either it is positive or negative, whatever. Okay, so we need to find I2. So the I2 is equal to 10 minus 6, that gives us plus 4 ampere plus I2. So the I2 is equal to minus 4 ampere. So this negative sign shows that the current is moving away. It means the current direction is moving away. So it means this is 4 ampere that is moving away from. So now we can balance this one. 6 ampere is 10 ampere is entering, and 6 and 4 ampere is leaving. So the sum of total current is also 0. It is another statement of this Kirchhoff first rule. So we need to find the direction. In order to find the direction, the current that is moving towards is taken as positive, the current that moves away is taken as negative. So I1 is entering, so it is taken as positive, sorry, I3 is taken as positive, and I1 is moving away, so it is taken as negative. So I2 we don't know about I2, so we can find I2 that is equal to negative, means it's moving away. So from the first rule we can find magnitude of any current when a current enters in junction then moving away, and then we also find the direction of that current. Okay, magnitude as well as direction. Okay, junction is the point where the current meets. Okay, thank you.